Hey guys, it's me, Miss A, coming back at you for another week of virtual learning. And guess what, guys? We officially now have 6 weeks left of virtual learning left. Yes, only 6 weeks, guys. That's 6 more lessons. That's almost nothing. So if you're starting to feel like you're losing steam, come on, stick with it. You guys have definitely got this. All right, so let's check out this week's goal. This week's goal is all about inverses, and we're going to be finding and also verifying inverses both graphically and algebraically. And I know that you guys might be like, ugh, graphing, but don't worry, it's not too much. And I know for my students, I'm only using Delta Math for graphing, and what's really nice is all you got to do is click, and then Delta Math creates the rest of the graph for you, which is really nice. So graphing is not going to be too bad this week. All right. This week's video is going to be broken down into 4 parts. And then also I'm going to be releasing another video for Friday for you guys to watch that talks about another aspect of inverses that I'll mention again later. And I will come back to this after each of the different parts of our video. So part 1, let's get started. So for these first few slides, I guess you could call them for lack of better terms. I know for my students, I have created these as essentially like a blank document so that you guys can kind of view this. I know it's a lot of information to write. So if you guys have access to a printer, this would be a great document to go ahead and print. I will keep it up on my Google Classroom post, and then also I will give access to other teachers so that they can give this out as well if this is something that you're interested in. So inverse functions, what are they? Well, you guys have been dealing with this little note up here that I wrote you, inverse operations, since you guys were in elementary school, right? And inverse operations, as you guys know it from elementary school, are adding and subtracting, multiplying and dividing. Then when you started to get into your algebra classes and algebra 2 classes, you guys started to learn about more inverse operations, such as squaring and square rooting, or cube rooting and cubing. And why are these considered inverse operations? Well, what one does, the other one undoes. So that's what inverse operations do. You know that adding and subtracting, essentially, for lack of better terms, cancel each other out. Same with multiplying and dividing, same with squaring and square rooting, same with cube rooting and cubing. There are plenty more examples of this, but I figured I would just point out some easy everyday ones that we typically deal with fairly often. So in a nutshell, what are inverse functions? They're functions that undo each other. So what one function is capable of doing, the other function is capable of undoing it. So they essentially cancel each other out. So we're going to take a look at the graphic part of this in the first part of our video, which is essentially looking at our inputs and our outputs. And remember, let's think about what math vocabulary term really describes input and output. The bigger, better math vocab word. Take a second to think about that. Input and output, the bigger, better math vocab word. All right, well, if you guys were thinking domain and range, you are right. Nice job. So what is going on here is that I have an example of an original function, or sorry, relation, and then its inverse relation. The reason that these guys are called relations is because, nothing was given to us to indicate that these were definitely functions. Remember, I'm gonna hit on functions versus relations again in the second video that I make this week, but I'll touch on it quickly here. We don't have enough information right now to know that these guys are definitely functions. So remember, everybody's a relation, just that some of us follow a special rule that make us functions. But either way, the domain and the range, or the input and the output of this original relation, and then if you look at the input or output or domain and range of your inverse relation, you're going to see that literally all of your domain values, your x values, became your range values or your y values. And then same thing here. All of your range values or your y values became your domain values or your x values. So this is kind of crazy. They kind of like flip-flop places, right? So they switch up with each other and become the opposite. So Down here is a graphic representation of that. So all of these points from the original relation are graphed here. All of the points from the inverse relation are graphed here. And if you notice in that process, like I was saying, these points end up getting flip-flopped. So for instance, this is the coordinate -2, +4. And then if you switched it around to +4, -2, it gets graphed down here, you'll see. And so these guys are being reflected over this line. It's like we can cut our graph or our paper or coordinate plane in half diagonally, perfectly. And this is the line y equals x. So all inverse relations and even inverse functions are going to be reflected over this line. That's the behavior that this is going to follow. And I mean, it kind of makes sense because if you look at this equation itself, y is equal to x, well, then that means that your y and your x values can be flip-flopped. That's kind of the way that I think about it. Since they're equal, they're being written as being equal, it's an easy flip-flop between them. So let's take another look at notation. Now, we're all very grown-up mathematicians here, and we're going to be using function notation. So make sure that you guys feel comfortable with this, all right? And two functions are considered inverses of each other if the following statement is true. If f of g of x, hold on a second, where do we remember this from? That's right. Last week, composite functions, right? So that's why those guys were so important because we're going to be using them. Again, that's going to be in video number 2 for the week. But if f of g of x is equal to x and g of f of x, so essentially the exact opposite, is equal to x, then these guys are going to be considered inverses of each other. And you don't have to call that other function g. You can give him his special name of f inverse. So f to the -1 does not mean f to the -1. We don't say it as f to the -1. Some of you guys might remember from your geometry classes that you saw on your calculator a button above the sine button, or maybe if you guys have your calculators handy, it says sine with a little -1, cosine with a little -1, and that represented an inverse. So that's the same thing here. And I wrote that down here to give you guys a little bit better explanation. So f of x is just function notation indicating that this is the original function. F to the -1 really means f inverse of x, and that's your function notation to indicate that this is an inverse function, okay? So regular old function, inverse function when you add up that little -1 power. And I'm going to come back to this in my second part of my video, but I did want to point it out because we do need to use proper notation as we go through these problems. So again, like I said, these first few worksheets that I have here, or slides, whatever you want to call them, I do have them available on paper copy just as is so that you guys can use them, especially the graphing. You don't have to recreate it in your notebook if you have access to a printer. So the first set of problems that you guys are going to be asked about are graphing inverses. And the cool thing about not Desmos, I'm thinking of our graphing calculators, Delta Math, is that when it gives you this graph, it says click the graph to make a point and click it again to erase it. Meaning if you click on any one of these little where the grid lines match up, it will plot a point for you. And then if you click on it again, it will erase it. But also if you do this, it will eventually, because it says you have to choose 5 points, it will eventually connect those dots for you the way that they should be connected. So all I did so far was identify 5 points here on this function that they've given us right now. And they said that we have to identify 5 points on the inverse function. So what does that mean? It means that we have to reflect it over the line y equals x. Remember, what we were looking at behind the scenes, what was going on in a function, or even some of our relations too, is that all of your x values become your y values for your inverse, and all of your y values become your x values for your inverse. So all I'm going to do is I created a table of values here to make this a little bit easier visually. And I just rewrote all of these points inside my table, and I'm going to flip-flop them. So instead of writing -8, 4, I'm going to write 4, -8. And then over here, I'm going to flip-flop this to be 3, -5. And then I've got 2, -2. I've got 1, 1. and then I've got 0, 4, all right? And these are gonna be my 5 new points for my inverse function, so I'm gonna go ahead and graph them. So 4, -8 is gonna be here. I've got 3, -5, which is gonna be here. I've got 2, -2, which is here. I've got 1, 1. Wow, weird situation, but let's think about that for a second. If I have to reflect over this line, is that point really going to go anywhere if it's on the line? No, right? So any point that exists on that line, y equals x, then you know for certain that that is going to be a point that exists for both the original and for the inverse. Where do we leave off? Oh, 0, 4 here. We've got one last point. Now, the cool thing in Delta Math is it's going to connect these 5 dots for you automatically, and it's going to create a line before you go ahead and you submit your response. So you are not going to have to do this by hand other than just your notes. And that's it. You guys created your inverse. And as you guys can see, if you folded your paper along this line here, you would have some really nice symmetry going on. And I'm just going to demonstrate that by folding this piece of paper as best I can to show you. You can see that the black and orange, each respective piece, they're going to land on top of each other like a beautiful butterfly. Oh, all right. Let's try that one more time. This time with an example that's a little bit more complicated because you've got a curve involved. Same directions. We're just going to find 5 new points. We're going to graph them. So all I did in advance was I just identified 5 points on this sideways looking parabola, and I'm just going to organize them in a table of values. And now I'm just going to flip-flop my values just like inverses react. So we've got -1, -5. We've got -2, 0. We've got -4, 4, and we've got -6, 0, and -7, -5. And I'm now going to just graph these points here. Also, before I get started, these 2 points here exist on the original relation. So what I'm going to do is, since they are on the line y equals x, I'm going to graph them as well because it's just going to help me make a nicer curve because I know that when it gets reflected, these 2 points aren't going anywhere. So I'm just going to add them in. All right, -1, -5, -2, 0, -4, 4, -6, 0, and I've got -7, -5. All right, and as you guys can see, this is going to be a parabola opening down. If you're having trouble identifying that, you can always put right here, V for vertex, and then when I rearrange this point, right, negative to get a -4, 4, this is my V for vertex, right? So this will help you to create your parabola. And there you go. Again, the nice thing about Delta Math is it is going to connect these 5 dots for you to make a nice parabolic curve. You don't have to necessarily worry about doing it by hand. All right, so that's inverses graphically. And that ends part 1 of our video. So if you guys are ready to roll, then you guys can get into Delta Math and you can click on identifying inverses graphically and go ahead and give that a shot. For my students, I'm still keeping up with those quizzes, so you can go ahead and check Google Classroom for some additional enrichment problems. All right, part 2. So in part 2, we're going to be moving on to actually 2, 3, and 4. We're going to be moving on to finding inverses algebraically. So finding inverses algebraically is actually very simple. The process itself is based out of like an Algebra 1 concept of just solving for a variable. But as you'll see, going through parts 2, 3, and 4 in this video, there's going to be an increased level of difficulty. So I like to think of part 2 as easy, part 3 as medium, and then part 4 as hard as far as level of difficulty. And you guys will see the different types of operations that you have to perform that'll become more and more obvious. So first of all the directions are going to say, for lack of better words, is the same type of direction that you see here. Find the inverse, right? And they're giving us a function in function notation. We need to remember that f of x is just a fancy way of saying y. So sometimes it's nice to remind yourself of that. And then you guys are probably thinking, okay, well, now what do I do? You gave me a function. How in the world am I going to find an inverse? Well, there's two steps to this process, okay? The first step to this process is you are going to switch where your x and your y are, okay? So you're going to switch x and y. Literally, we're going to rewrite this function with x over here and y over here. And then the second step is we're just going to solve it for y, because we don't like when our equations say x equals, unless that's what you're being asked to solve for. Typically, when we're talking about functions or relations, we like them to say y equals. So we're going to go ahead and do that. So I'm just going to rewrite this first step, as x equals 1/2 y minus 8. So as you can see, it changed nothing except for where the x and the y appear in this equation. And now, step 2, I'm just going to rearrange and I'm going to solve for y. So that means I'm going to add 8 to both sides. So I'm going to get x plus 8 is equal to 1/2 y. As a reminder for those of you guys out there who are in the fraction haters club, remember, how do you get rid of a fraction? Yes, you multiply by its reciprocal. So flip that fraction, 2/1, right? So we're going to multiply both sides by 2/1 so that these guys cancel and that y ends up by itself. And remember, when you're multiplying, you've got to multiply everybody. So make sure you distribute that too. So you guys are going to get 2x plus 16 is equal to y. Now we're not done. Yes, we solved for y, but those were the algebraic steps. Maybe we should add in a step 3. Step 3 is write in function notation. All right, so we're going to rewrite this in our proper function notation. Since we found an inverse, we're going to use that little -1 power, right? So f inverse of x is equal to 2x plus 16, and that is your final answer. Not too bad. All right, we're going to continue this process for all of these example problems. I'm going to speed it up just a little bit because the reason I want to go through these examples with you is just to remind you of those silly little things that sometimes we forget, like how to get rid of fractions, maybe taking advantage of a situation where we can cross multiply, because I know we love doing that, and things like that. So take a look. All right, I'm just switching my x and y here while I set up. All right, so step 1 is to find an inverse function. You are going to switch your x and your y, which I've done here, and now we need to solve for y. Couple different ways that you can do this. Again, you can always get rid of a fraction by multiplying by its reciprocal, but the thing that makes me nervous here is that my y is in my denominator. So whenever I have a variable in the denominator and I'm solving for that variable, here's what I suggest doing. Turn this into a proportion and cross multiply. A proportion is two ratios or two fractions set equal to one another. So if I put this guy over 1, they're set equal to each other. And now how do you solve a proportion? You cross multiply. So we're going to cross multiply here, x times 5y, and I'm just going to put our coefficient out front and my variable second, so 5xy. 1 times -4, I'm just going to assign the negative to be to the 4. You can certainly assign it to be to the denominator. It doesn't matter. Just don't assign it to everybody. Okay. So we've got 1 times -4 is -4. Now I still need to get this y by itself. So that means I want to get rid of the 5 and the x. And since it's all multiplication here, I'm just going to get rid of it using division, right? So I'm going to divide by 5x. And I get y is equal to -4/5x. So we completed step 2. Let's do step 3, which is turn this into function notation. So f inverse of x is equal to -4/5 x, which, hold on a second. That's really weird. They're the same. We must have done something wrong, right? No, stop it. Be confident in yourselves. Listen, this does not happen often, but it does happen every once in a while. So don't freak out if your answer comes out to be the same as the original, all right? So don't worry about that. Also, remember, a negative sign for a fraction can be attached to the top, the bottom, or out front. It all means the same thing. The fraction itself is negative, all right? All right, number 3. So we're going to find the inverse here. Again, we're going to switch our x and our y. So x is equal to the square root of 4y. If we want to get to that 4y, we are definitely going to have to get rid of that radical. So what is the inverse operation for square rooting? You guys got it. Squaring. We got to square both sides. So we've got x squared is equal to, squaring and square rooting cancel, 4y. Get that y by itself. Let's divide both sides by 4. So we've got x squared over 4 is equal to y. Let's write that in function notation. F inverse of x is equal to x squared over 4. Done. Got a few more examples here for you. Again, I'm just trying to remind you of the different types of problems that you guys are going to come up against. Fraction exponents. Yes, they're not going away, guys, all right? So here we go. We've got y is equal to, oops, sorry. Oh my gosh, I'm already making a boo-boo. X is equal to 3y to the 3/4. All right, so be careful here. We need to get y to the 3/4. I'm going to highlight this by itself before we can deal with that fraction exponent. So let's get rid of it. Let's divide by 3 to get rid of it. So we're going to have x over 3 is equal to y to the 3/4. Okay, now that we have this variable to its exponent by itself, we're going to get rid of it. Now remember, how did you get rid of fractions before? You multiplied by the reciprocal, right? We're going to do the same thing here, but since our fraction is an exponent, we're going to keep our reciprocal fraction in the exponent. So we're going to raise it to the 4/3 because a power to a power means multiply, right? So same concept, just working in a different part of the problem, in the exponent part. So now these guys will cancel each other out, but that means we have to raise the other side to the 4/3 power, okay? So we're going to get x over 3 all raised to the 4/3 power is equal to y. Let's write that in function notation. F inverse of x is equal to x over 3 to the 4/3 power. Now in Delta Math, this is a multiple choice section. So just be careful if we saw this answer with a 4/3 power attached to the x and a 4/3 power attached to the 3, then you know that obviously this is a possible answer, but they're not going to give you both as an option. It's just that, let's say you didn't see this, but you did see one where both of these items had the 4/3 power, you would know that that's the correct answer for multiple choice. All right, let's try another fraction exponent again. Switch your x and your y. So we've got x is equal to 2y all raised to the 5/2 power. Now, what's interesting about this one is the 5/2 power belongs to everybody. So some of you might be tempted to distribute this, but no, that's going to make more work, right? So let's make our lives a little bit easier and just get rid of it right now. Let's get rid of this fraction exponent by multiplying by its reciprocal, also known as raising to the reciprocal power, right? So to the 2/5, these guys will happily cancel each other out, setting our 2y free, and now our x is going to have a new exponent, right? So we've got x to the 2/5 power is equal to 2y breaking free. Get that y by itself by dividing by 2. So we've got x to the 2/5 power all over 2 is equal to y. We'll write that in function notation. So f inverse of x is equal to x to the 2/5 power over 2. And you're done. All right, this concludes part 2 of our video. So if you guys are ready, you can go ahead and jump into Delta Math. Inverse of various functions, MC. MC stands for multiple choice. And for my students too, remember there is some reinforcement in the quizzes that I've posted on Google Classroom. All right, part 3, we've got medium level problems. We're going to kick it up a notch here, guys. So I've got 3 different examples for you. A little bit more complicated, as you can see. The directions look like they have changed, but they have not. It's the same directions. They're asking you the same thing, just looks different. It says for this function, find f inverse of x. So find the inverse. Same exact situation here, following the same 3 steps. So first, we are going to switch our x and our y. So x is equal to y to the 7th over 7. Again, you're in a situation where you've got to get rid of this 7. You guys can certainly multiply by the reciprocal, which would be 7 over 1 on both sides. Or for those of you who did like cross multiplying, you can turn this into a proportion and cross multiply. That's what I'm going to do. So x times 7 gives me 7x. 1 times y to the 7th gives me y to the 7th. And now I need to get rid of the 7th power. Well, if this were the 2nd power, you'd be squaring it. How do you get rid of squaring? You square root. If this were the 3rd power, right, cubing, what's the opposite of cubing? It would be cube rooting. So since this is the 7th power, how do I get rid of it? 7th rooting. Make sure you 7th root everything on this side. So when I do that, these guys are going to cancel. So I'm going to get the 7th root of 7x is equal to y. And now we just have to write that in function notation. F inverse of x is equal to the 7th root of 7x. Done. All right, example 2. Switch your x and your y. X is equal to y to the 3rd minus 7. I have to get this y to the 3rd by itself first. So I'm going to add 7 to the other side. So x plus 7 is equal y to the 3rd. And here we are again. What is the opposite of cubing? Cube rooting. So we're going to cube root both sides. Make sure you get that entire expression underneath. So we've got the cube root of x plus 7 is equal to, these guys cancel, y. So we're just going to write that in function notation. F inverse of x is equal to the cube root of x plus 7. Make sure you extend that radical symbol over the entire expression. All right, a little bit more challenging here. We've got another fraction exponent going on. So switch your x and y. So you've got x is equal to y minus 8, all raised to the 1/4 power. I cannot get inside this set of parentheses until I get rid of this guy here, right? So again, he's a fraction. How do we get rid of fractions? We use the power of the reciprocal. So in this case, I'm going to raise it to the reciprocal power to get rid of him. So the 4th power. So I'm going to have x to the 4th is equal to, these guys are going to cancel, and I'm going to have y minus 8 break free. Now I'm going to add 8 to the other side, and y is by itself. So we're going to write this in function notation. F inverse of x is equal to x to the 4th plus 8. And those are your 3 examples for your medium level problems. So this concludes part 3 of the video. So if you guys are ready, go ahead into Delta Math and click on multi-step function inverses level 1. All right, save level 2 for later. All right, part 4 of the video, last part, 3 more examples. These are definitely considered the harder of them. Again, just increasing the level of difficulty to show you guys the difference. All right, here we go. Let's switch this x and y. Again, these directions look similar to each other from the last one, but they're still asking us, here's a function, find its inverse. So we've got x equal to 2y to the 7th plus 5. If I want to get this y to the 7th, I'm going to use my highlighter for a visual effect here. I need to get rid of the 5 and I need to get rid of the 2. The 5 is going to go first. Subtract him over to the other side. So x minus 5 is equal to 2y to the 7th. I still need to get y to the 7th by itself, all right, before I can get to that y. So that means that I'm going to have to divide both sides by 2. And so I'm going to get x minus 5 all over 2 is equal to y to the 7th. And now I can finally get rid of that pesky 7th power. Remember, this is just like a problem we did earlier. I'm going to use the 7th root to get rid of the 7th power. Gotta move over here. So I've got the 7th root of, make sure you get that entire fraction underneath. X minus 5 all over 2 is equal to y, and we're just going to rewrite that in function notation. So f inverse of x is equal to the 7th root of x minus 5 over 2, and we're done. Example 2 here, switch my x and y. X is equal to 3 times the quantity of y plus 7, all raised to the 1/4 power. All right. If I want to break inside that set of parentheses, there's 2 things that I need to do. I got to get rid of the 3 out front, and I got to get rid of the 1/4 power up top. And I have news for you. The 3 has got to go first. All right. We can't tackle this exponent yet. We don't want to be raising things to the 4th power, making our life more complicated here, right? So divide by 3 so these guys cancel out. So we've got x over 3 is equal to y plus 7 all to the 1/4 power. Again, how do I get rid of fractions? I use the power of the reciprocal. Raise that to the 4th power. Okay, so I've got x over 3 all raised to the 4th power is equal to y plus 7 breaking free. I'm going to subtract 7 to the other side. Oh no, my battery is going to die. Uh-oh, we're going to go fast here. All right, x over 3 all raised to the 4th power minus 7 is equal to y. I'm not going to rewrite in function notation since my MacBook is going to die. But remember, if these guys were both raised to the 4th power, that is a possible answer from multiple choice. All right, last one. X is equal to y plus 4 all over 7, all raised to the 7th power. I got to get rid of that 7th power. So we're going to 7th root everybody, this whole side and this whole side. So I've got the 7th root of x is equal to y plus 4 all over 7. Now I can deal with this fraction. Again, you can cross multiply if you just put this guy over 1. So I'm going to have 7 times the 7th root of x is equal to y plus 4. I'm going to move that 4 over by subtracting it. So 7 times the 7th root of x minus 4 is equal to y. Make sure you rewrite that in function notation. Oh my gosh, we did it. Okay, here you go, guys. Part 4 of this video, if you're good to go, Delta Math, multi-step function inverses level 2. And hey, get ready for part 2 of this video coming out on Thursday.